High stakes. I hope I can deliver. So my name is Jonathon Keeney. I'm just going to jump right in because I only have 5 minutes. So BioCompute is a descriptive standard for documenting workflows. So how you arrived at some particular decision or piece of data in a way that provides some context. So something as simple as why did you choose the particular reference that you choose, and providing some justification, for example. So just to provide some background for all this, the roots go back to 2012 when the United States NCBI was discussing how to coordinate all of this different but very related data into what would ultimately become known as the BIO project, which is the data model you see here. And so during all those discussions, it was proposed, wouldn't it also be neat if we could have some sort of computable framework for the metadata, so you could understand, how a particular piece of data in that repository was generated. And unfortunately, the idea was still a little bit nebulous at the time, and so it did not make it into BIO project. But the seed had kind of been planted, and so on the regulatory side, the need for this, I think, was much more concrete, in that a lot of industry sponsors would submit something to the FDA, the reviewers would kick it back with need for clarification if there was any type of computational component to it. I'm told this happened almost always, because usually they would just say something to the effect of X software was used and that was it. So they'd have to kick it back. Maybe they'd resubmit, maybe it worked, maybe it didn't. They might go back and forth multiple times and take months and millions of dollars. And this was all just to get the FDA enough information to make a scientific decision. So it was starting to cause a lot of frustration on both sides. And so in 2014, the Genomics Working Group at the FDA met to tackle this problem. And that idea from 2012 was proposed, which by now is being called BioCompute, and it was accepted. So lots of meetings, lots of discussions, lots of planning to sort of formalize the problem statement and the goals and the sub-goals and so forth, lots of publications. And so after input from hundreds of individuals across dozens of institutions, we ended up with this data model here. Unfortunately, I don't have time to get into it, but it has very strong data provenance, descriptive metadata, and user attribution. And so at the beginning of 2020, it was formally standardized as IEEE 2791-2020 through their open access project. I'll make these slides available if you decide to go check it out. It's this 2791 object.json file that you'll start with. It's all in JSON. And within months, it was accepted at the FDA for regulatory submissions, which is like light speed. And it's still to this day, in fact, the only framework standard to have ever been adopted by the FDA's Data Standards Board. So that was a really big win for us. And so the focus shifted at that point to building out an ecosystem of tools to work with the standard. And so that includes genomics platforms and workflow languages. I think with respect to the session focus of AI moving forward, I do think that there's a potential role for BioCompute to help there too. I think as human scientists, we sort of intuitively understand this idea that science is a self-correcting process. And so there may be some things in the literature that are not correct. In fact, we just heard a keynote about that, in fact. But LLMs don't understand that. So if we can have some way of explicitly pointing to some assertion in the literature and saying why we know what we think that we know, and do so in a way that's compatible with natural language, then we might have a better framework that it's less ambiguous how some new result affects prior knowledge, and that might kind of give us a better foundation for this. So this is still a very new concept, but I do think it's a place where BioCompute can meaningfully contribute. So I'll just finish by showing one example that is not a typical sort of pipeline submission to the FDA use case, because this might be more relevant. GlyGen is a big knowledge base, kind of like the Rosetta Stone of the glycan language that all cells use and most proteins use. It's a very large multi-institutional knowledge base supported by the United States NIH Common Fund across multiple institutions. And so the framework for this site uses BioCompute. So they use it for data traceability and versioning and transparency and harmonizing lots and lots of data as sort of an interface for all these different data sources. And in fact, you can download BCOs for any of them to understand how a particular piece of data ended up there. So I don't have time to thank anywhere near enough people that need to be thanked. I will just quickly thank Raja Mazumdar and Vahan Simonyan. They were the two original architects of this idea, and they worked really hard to articulate it, which was the hard part, I think, and they're the reason it got so much momentum. And in my last 5 seconds, I will also acknowledge our NIH funding and our FDA funding, and I'm happy to chat more about it. Thank you very much.